The universe speaks in riddles. It stretches endlessly outward, yet began from a single, silent point. It is governed by laws so precise, they can predict the orbit of a comet centuries in advance. Yet it's haunted by mysteries so deep, they defy even our best equations. We live within a cosmic paradox, a universe that appears both exquisitely ordered and chaotically uncertain. A universe that expands with a whisper but collapses in equations we cannot yet solve. It is as if reality itself is a puzzle left behind by something far more intelligent than us. A hidden truth encoded in the stars, awaiting decipherment. The more we learn, the more we feel the tremor of the unknown beneath our feet. And perhaps this is why we search for the one equation to rule them all. A single, elegant idea that can explain everything, from the dance of galaxies to the jitter of quantum particles. The theory of everything. But what if that theory isn't a number or a formula, but a story? In the beginning, there was only silence, no space, no time, just a singularity, infinitely dense, impossibly small. A place where gravity crushes everything into a single point, and time comes to a halt. From this nothingness, everything erupted. The Big Bang was not an explosion, but an unfolding, an opening act to the most profound story ever told. In less than a second, energy surged, matter formed, space expanded, and time began to tick. The universe took its first breath. But in this violent birth, something was seeded, something buried deep in its structure. A whisper of unity, a hidden thread, a promise that all the forces of nature, gravity, electromagnetism, the strong and weak nuclear interactions, were once one, a single force. A cosmic harmony shattered as the universe cooled. But the echoes remain. We see them in the equations that almost match, but not quite. In the particles that behave like waves, and waves that collapse like dice rolls. In the stubborn refusal of gravity to be tamed by quantum mechanics. Something is missing, like a puzzle with a piece that never quite fits, no matter how we twist it. The standard model of particle physics is a triumph. Quantum field theory explains nearly everything we can measure. But gravity remains an outsider, a monarch without a throne in the quantum realm. Every theory that tried to unify them, string theory, loop quantum gravity, M-theory, has whispered secrets, but none have spoken the final word. None have sung the song of everything. So we look up. We look inward. We build machines to smash atoms apart, hoping that in the fragments we will find the signature of truth. We send telescopes into space, listening to the static left behind from creation's first cry. We write equations with trembling hands, chasing beauty, simplicity, inevitability. We speak of symmetry and broken symmetries, of dimensions we cannot see, of particles that vanish before we can grasp them. We theorize multiverses, cosmic inflation, strings vibrating in invisible dimensions. We are desperate to understand, and perhaps beneath all this science is something far more human, a longing for coherence, for a cosmos that makes sense, for a universe that not only exists, but tells us why. We are not simply looking for how things move, we are searching for the reason they move, for the purpose behind the particles, for the meaning inside the math. You, sitting here now, are made of atoms forged in the hearts of stars. You are a structure built from quantum probability and gravitational necessity. And yet you think, wonder, love, and dream. You ask why. Why does gravity pull? Why do particles have mass? Why does time move forward? Why do we exist at all? These are not idle questions. They are the heartbeat of every physicist, every philosopher, every child who ever looked up at the stars. Somewhere, buried in the equations we have yet to discover, may be a deeper truth, a truth that connects everything, the micro and the macro, the mind and the matter, the particle and the person, the theory of everything. And yet, for all our advancements, the answer still lies ahead. Like a shadow we cannot outrun, a shape in the fog, just beyond reach. But it is there. We feel it. Every mystery we solve only opens a door to another. Every law we write leaves a footnote of uncertainty. We know there is more. To understand this, we must go back. Before science spoke with mathematics, it whispered through myth. Long before equations were etched onto chalkboards or theories debated in great halls, humanity looked to the sky and told stories. The stars were not just distant lights. They were gods, hunters, serpents, and spirits. To the ancient Sumerians, the universe was born from the mingling of freshwater and saltwater gods, Apsu and Tiamat. In Hindu cosmology, the world cycles endlessly through creation and destruction, with Brahma dreaming the cosmos into being. The Egyptian god Atum willed himself into existence from the waters of chaos, then formed the world from his own essence. Each myth echoed something profound, the belief that everything came from one thing. That order could be born from chaos. That there was an origin, hidden, sacred, unknowable. And so began humanity's first theory of everything. Not in laboratories, but in temples. But myths, for all their beauty, gave way to questions. Why did the stars move as they did? Why did seasons change? How did fire behave the same, whether in one village or another? Curiosity was no longer content with stories. It sought patterns. And with that, the first scientists were born. Thunbi, Babylonians mapped the heavens with obsessive precision, tracking planetary motions not to understand physics, but to read the language of the gods. Yet their meticulous observations would one day lay the groundwork for astronomy. Then came the Greeks, and with them, philosophy took its first step into science. Thales of Miletus declared that everything came from water, not as myth, but as matter. Anaximander posited an apeiron, an infinite, boundless substance from which all things emerge and return. Heraclitus saw the universe as ever-changing fire, while Pythagoras glimpsed a deeper truth, that numbers, not elements, might underlie reality. The idea that the cosmos had order, that it could be measured and reasoned through, was a revelation. The universe, it seemed, had a structure, a hidden code. Plato imagined perfect forms behind the imperfect shadows of reality. His student, Aristotle, sought to classify all things by their nature and purpose. He divided the world into 4 elements: earth, air, fire, and water, and declared that heavenly objects moved in perfect circles, untouched by the imperfections of earth. For centuries, his model held sway, embraced by church and scholar alike. It made sense. It gave the heavens nobility, and earth its humble place beneath them. But it was wrong. The sky, ever patient, began to reveal its contradictions. The planets wandered, not in perfect circles, but in loops and reversals. This celestial misbehavior troubled thinkers across generations. Enter Ptolemy, whose geocentric model tried to save appearances with deference and epicycles, circles upon circles, complexity layered over error. It worked, but only just. Then came the whisper of heresy, Copernicus. He dared to suggest that Earth was not the center, that we orbited the Sun. His heliocentric model simplified the math, made the dance of planets elegant once more. But simplicity was not enough. Galileo looked through a telescope and saw Jupiter's moons, orbiting not Earth, but Jupiter. He saw Venus change phases, as only possible if it orbited the Sun. Reality, not theory, was now on the side of revolution. He was silenced, but the damage was done. And then, in the 17th century, the universe began to speak in a new tongue: mathematics. Kepler abandoned circles for ellipses, finding that planets moved not in perfection, but precision. And Isaac Newton, with the fury of genius, carved the heavens open with his laws of motion and universal gravitation. He united Earth and sky under the same principles: an apple falling, a moon orbiting, both obeying the same force. For the first time, the cosmos seemed within reach. This was humanity's first great unification. One force, gravity, ruling all motion. But Newton was cautious. He refused to speculate on why gravity worked. "Hypotheses non fingo," he wrote. "I feign no hypotheses." He could describe the cosmos, but he would not presume to understand its deeper nature. Still, his laws held for centuries, guiding ships, wars, and dreams, yet even this triumph had its cracks. Light, the universe's oldest messenger, refused to fit neatly into Newton's clockwork cosmos. It behaved as both particle and wave, flickering between certainty and paradox. When James Clerk Maxwell formulated his equations of electromagnetism, he revealed another unification: electricity, magnetism, and light, bound together in a single framework. Another force, once thought distinct, now seen as part of a greater whole. The age of unity had begun, but it was not peace. It was tension. As the 19th century gave way to the 20th, reality began to splinter. Tiny particles disobeyed the rules. Time refused to remain absolute. Space warped under the weight of mass. Einstein arrived like a prophet with chalk and rewrote the universe. Special relativity shattered the idea of a universal clock. Time slowed. Length contracted. Simultaneity became an illusion. And then came general relativity, his masterpiece. A vision of gravity not as a force, but as the curvature of space-time itself. Suddenly, the cosmos became a fabric, bent and rippled by mass and energy. Newton's invisible hand was replaced by geometry. But if Einstein ruled the grand, then the quantum realm was a revolution of another kind. Max Planck's desperate attempt to solve blackbody radiation unleashed quantum theory. Electrons did not move in neat orbits. They jumped, vanished, appeared elsewhere. Heisenberg's uncertainty principle declared that we could never know both position and momentum. Schrödinger's wave function blurred particles into probabilities. Quantum mechanics was not just a new theory. It was a new reality. One where observation itself changed the outcome, where particles tunneled through barriers and cats existed in twilight states. Here lay the second great schism. Gravity and general relativity ruled the large. Quantum mechanics ruled the small. Each was breathtakingly successful, and yet they could not speak to each other. Their equations clashed. Their assumptions contradicted. They were truths that could not coexist. This was the modern paradox. The closer we came to understanding the parts, the more we realized how broken the whole remained. Gravity had no place in the quantum world, and quantum uncertainty had no room in Einstein's smooth spacetime. Something was missing. A bridge. a language both could understand. And so the dream began anew, a theory that could unify everything, one idea to reconcile the large and the small, to explain the birth of the universe, the death of black holes, the ripples of space-time, and the jitter of quarks. A theory that could reveal not only how the universe behaves, but why it must behave that way. This dream is not new. It is as ancient as myth, as modern as physics. It has worn many faces: God, logos, ether, field, string, and in every age it has been the same longing to know, to understand, to grasp the hidden order behind the stars. Now we find ourselves at the edge of this pursuit, armed with particle colliders, cosmic observatories, and equations so elegant. They border on poetry. We ask again, what holds it all together? And more urgently, why does anything hold together at all? Beneath the French-Swiss border, buried in a cathedral of concrete and steel, hums a machine that dreams in circles. It does not speak. It does not see. But it listens to the tremble of the universe, and when it awakens, it does not whisper. It roars with the energy of creation. This is the Large Hadron Collider, the greatest scientific instrument ever built by human hands. Not a telescope, yet it peers into the heart of reality. Not a spaceship, yet it explores the dawn of time. It is a ring of metal and magnets. 17 miles in circumference, colder than outer space, and more powerful than any force humanity has ever commanded. But to call it merely a machine is to miss the truth. The LHC is a mirror, polished with equations and ambition, held up to nature to ask, what are you made of? Here, buried beneath the earth, humanity performs its most delicate surgery on the fabric of the cosmos, smashing particles together at nearly the speed of light, peeling back the layers of matter, searching for the fingerprints of the universe's origin. And in doing so, we are not merely studying nature, we are confronting it, probing the seams of existence, looking for signs of a deeper order. It is a modern cathedral, not of worship, but of wonder. And the question it was built to answer is one of the oldest. What is everything made of? The mission began not with tools, but with tension. For decades, physicists had been caught in a beautiful but incomplete framework, the Standard Model. It described the zoo of particles and the forces that govern them with astonishing accuracy. Quarks, leptons, bosons. It had names and rules for everything, except gravity, and mass, and dark matter, and dark energy. The Standard Model was a map with edges torn away. It worked, but it knew it was not the whole story. So the mission was born. To push deeper, to recreate the moment after the Big Bang, to reveal particles so elusive they had danced beyond our reach for generations. The machine was built not just to observe, but to provoke, to challenge the universe, to force it to reveal its hidden hand. And at the center of this mission was a mystery: mass itself. Why do particles have weight? Why does the photon fly massless, while the W and Z bosons drag like anchors? There was a ghost in the equations, a theoretical field, suggested decades earlier by Peter Higgs and others, that might endow particles with mass, but it had never been seen. It was a rumor in the mathematics, a whisper in the quantum vacuum. The LHC was designed to hunt it. And so, in 2012, after decades of planning, collaboration, and almost mythical anticipation, the Collider came to life. The world watched as protons were accelerated to near-light speeds, forced to collide head-on in bursts of energy hotter than the core of a star. Detectors the size of cathedrals, Atlas CMS, recorded the aftermath in bursts of data. Billions of collisions, trillions of fragments, the debris of miniature universes. And then it happened. A signal, a particle, heavy, elusive, consistent with the long-sought Higgs boson. The field that gives mass to everything had been found. But the story did not end there, because the discovery of the Higgs was not a conclusion. It was a beginning. The LHC had proven it could see beyond the veil. Now the mission was to go further, deeper, stranger, to search for supersymmetry, extra dimensions, dark matter particles, and echoes of a grand unification, perhaps even clues to quantum gravity, some bridge between the smooth curves of relativity and the granular chaos of quantum mechanics. And in this search, the LHC itself became something more than a machine. It became a character in the great human story of discovery. Like Galileo's telescope, Newton's prism, or Hubble's mirror, it was a tool that redefined the possible. It did not answer all our questions, but it asked better ones. Across the Earth, in the silent vacuum of space, another mission began. Not beneath our feet, but far above our heads. A telescope, shaped like a golden flower, unfurled its wings. In the darkness beyond the moon, the James Webb Space Telescope, where the LHC looks inward to the smallest building blocks, JWST looks outward to the ancient light from the edge of time. It does not collide particles. It collects whispers, photons that have traveled for billions of years, stretched by the expansion of space, bearing witness to the infancy of the cosmos. And like the collider, JWST too was more than a machine. It was a prophet in orbit, crafted with mirrors of beryllium and gold, cooled to just a few degrees above absolute zero. Its mission was to glimpse the first stars, the first galaxies, the first structure, when the universe emerged from darkness and began to form meaning. But perhaps more importantly, it was sent to search for signs of life, for atmospheres wrapped around distant worlds, for the spectral fingerprints of biology on alien air. One looks inward, the other outward. One breaks apart, the other gathers, and, between them, a theory waits to be born. For in the tunnels beneath Geneva and the quiet orbit beyond Earth, humanity has placed its hopes not in myths or speculation, but in vision and precision, in machines that can test the fabric of space-time, in sensors that can see the red-shifted glow of the first dawn. These instruments are not just metal and math. They are extensions of our senses, our longing, our boldness. They are the fingers we stretch into the void, hoping to touch something real, and in their silence, they speak of purpose. They whisper, what lies beyond the known? They ask, what is the nature of reality itself? The mission is not just scientific. It is existential. It is not merely about knowledge, but identity. What is a human in a universe of quarks and galaxies? What is purpose in a cosmos that may be infinite and indifferent? The collider will smash particles again and again, trying to break the illusion of simplicity. The telescope will stare into the abyss, hoping to glimpse a reflection of ourselves. And we, suspended between the infinitely large and the impossibly small, wait for the revelations. For we did not build these machines just to understand the universe. We built them to understand ourselves. It began, as many revelations do, with something that wasn't supposed to be there. At first, it looked like noise, a statistical flutter, a ghost in the data stream. Detectors at the LHC recorded a signal just a fraction heavier than expected. A particle, unknown, unpredicted, appearing for the briefest heartbeat in the chaos of collision. It was like hearing a single note out of tune in a symphony, a subtle discord that refused to go away. Most anomalies fade under scrutiny. They evaporate in the heat of repetition. But this one stayed and grew louder. Scientists gathered like storm chasers around a distant, flickering cloud. Data poured in. The signal persisted. It did not belong to the standard model. It danced on the edge of theory, its mass too high, its behavior too strange. For every collision, there was a chance, 1 in a billion, that this mystery would show itself again. And when it did, it shimmered like a question mark written into the equations of reality. It wasn't just what it was what it wasn't. It wasn't a Higgs. It wasn't a quark or lepton. It wasn't predicted by any of our neat, comfortable models. The LHC, in its endless circular pursuit of truth, had stumbled onto something ancient and new, and in doing so it had whispered, "There is more." To grasp the scale of what this meant, imagine this. The standard model is like a majestic cathedral. Inside are pillars of particles, arches of symmetry, stained glass windows of interactions, all meticulously crafted over decades. We've studied its structure, traced its history, and declared it beautiful. Because it is. But what if, beneath the foundation, there's a tunnel we never noticed? A door, sealed and forgotten, that opens into a deeper crypt of truths? This was that door, and it had begun to open. Across the ocean, scientists using the James Webb Space Telescope began noticing something equally strange, an excess of infrared light in the early universe. Galaxies, impossibly bright and massive, appearing far earlier than expected. They shone not like children of the young cosmos, but like elders from a universe far older than our models allowed. Stars formed faster. Structures grew sooner. The universe, it seemed, had hurried into complexity with breathtaking speed. It was like opening a book you thought you'd written, and finding entire chapters you didn't remember composing. Both anomalies, one microscopic, one cosmic, spoke a similar dialect, a breakdown of the known, a defiance of expectation. And in both cases, scientists began to whisper what they dared not yet publish. Are our models wrong? The tension grew. Every experiment now carried the weight of anticipation. Could this new particle be evidence of supersymmetry? A hidden partner to the particles we know? Or was it something stranger, a graviton hinting at the unification of quantum mechanics and gravity? And those galaxies, were they products of new physics, unknown forces shaping the early universe? Old theories began to crack under the weight of new data. Like frost on glass revealing the contours of something behind it, these anomalies weren't just flaws. They were maps. Maps pointing somewhere unexpected. But science does not leap. It steps, and each step must be sure. So the collisions continued. The light kept pouring in. The LHC upgraded its detectors, its energy. JWST peered deeper still, tuning itself to frequencies few dared dream of detecting. And beneath every calculation, behind every simulation, a question began to pulse louder. What are we missing? In labs and universities across the world, chalkboards filled with equations stretched into new dimensions. Theoretical physicists played with unfamiliar symmetries, tried out new algebras, postulated new fields. Perhaps, some suggested, we are seeing evidence of a fifth fundamental force. Perhaps, others said, These are echoes from another brain, a parallel universe bleeding into ours. And a few dared the boldest whisper of all. Maybe, just maybe, this is the edge of the theory of everything. The idea sent chills down spines. Because to find a new particle is to find a new truth, a new law, a new layer of reality. And with every confirmed collision, every unexpected star, that truth drew closer. But this wasn't just science. It was a transformation of narrative. Because the story of the universe had always been a story of emergence. From simplicity to complexity, from silence to song. Hydrogen into stars, stars into elements, elements into life, life into thought. And thought, now, probing back through time, was discovering something hidden at the base of it all. A deviation, a clue, a contradiction in the script. And contradiction is where all great stories begin to change. The particle from the collider. The ancient galaxies in the sky. Two clues, separated by scale and method, but united in meaning. They pointed to a universe that was not just expanding, but evolving in ways we had yet to understand. And if the rules were changing, or had never been complete to begin with, then everything was back on the table. The Standard Model, our proudest framework, was not wrong, but it was incomplete, like a masterful painting missing its final strokes. The theory of everything, if it existed, would have to explain this new anomaly. It would have to reconcile the strange behavior of this rogue particle with the eerily early formation of stars. It would have to unify what we had long believed to be separate. It would have to make the universe whole again. Scientists gathered at conferences with a quiet kind of reverence, not because they had the answers, but because they could feel the page turning. They spoke with caution, with excitement buried beneath restraint. No one wanted to declare discovery too early, but no one could ignore the signs. The universe, for the first time in decades, was surprising us again, and surprise is the seed of revolution. Cameras weren't rolling. The public didn't yet know. But in the quiet hum of machines and the glow of computer screens, something ancient stirred. A riddle more elegant than myth, more enduring than any god. It did not shout. It did not flash. It simply appeared, over and over again. There, in the debris of colliding protons. There, in the red-shifted glow of baby galaxies. A whisper in two tongues saying, "Look again." We had torn holes in reality, and something was shining through. But this was only the beginning. The deeper we looked, the less we understood. What began as a flicker, an unexpected particle here, a too-bright galaxy there, was now a roaring chorus of contradiction. Data from the Large Hadron Collider and James Webb Space Telescope continued to arrive in waves, and with each bite, the universe seemed to grow stranger. The anomalies were no longer isolated. They were stacking, clustering, refusing to go away. And with them came a question that chilled the scientific soul. What if the foundation is flawed? In Geneva, the particle in question, now confirmed and catalogued, did more than challenge the Standard Model. It ridiculed it. The particle's decay patterns didn't follow expected paths. Its interactions were inconsistent with any known force. Worse, it seemed to influence particles around it, not directly, but subtly, as if space itself was bending differently in its presence. It wasn't just heavy, it was unruly. Some called it a pseudo-graviton. Others speculated it was a bound state of particles from a higher dimensional brain. A few whispered that it might not even be a particle at all, but a wrinkle in the field, an echo of something the model could not resolve. Whatever it was, it didn't fit. And it wasn't alone. The early galaxies detected by JWST were equally insubordinate. Some emitted light older than their predicted birth. Others rotated too smoothly, as though immune to the chaos of cosmic infancy. One galaxy, in particular, designated JX372, appeared so massive, so organized, and so early in time that it bordered on the impossible. It was like finding a mature city with skyscrapers and highways in the middle of a desert where no civilization should exist. The calculations were redone, the models rechecked, but the galaxy remained, defiant, perfect, and in both domains, particle and cosmic, other anomalies began to multiply. At Fermilab, the magnetic moment of the muon still refused to conform, its wobble hinting at unknown forces. In dark matter experiments buried beneath mountains, detectors caught flashes. False alarms or forbidden particles? No one knew. And in deep space, certain regions appeared to exhibit preferred directions of expansion, breaking the sacred principle of isotropy. The universe was not only expanding, it was misbehaving, and the interpretations were fracturing. One camp of physicists, grounded in tradition, insisted that this was all statistical noise, that with enough time, data would smooth out and normalcy would return. Another camp leaned into exotic possibilities, dark sectors, mirror universes, emergent space-time. Some even revived ideas once considered fringe: pilot wave theory, varying speed of light, non-local hidden variables. The old boundaries were cracking. Papers, once dismissed as theoretical fantasy, were now cited in earnest. The frontier had shifted, and within that shift was a deeper unraveling, not just of science, but of certainty. What do we do when our most trusted frameworks betray us? This was not the first time science had faced revolution. Newton had been eclipsed by Einstein. Einstein undermined by quantum theory. But each time, a deeper order had emerged, a grander symmetry. Now, no symmetry felt safe. Unification seemed further away than ever. The more we searched for one theory, the more the universe seemed to offer many. Like reflections in a shattered mirror, each discovery hinted at something whole, but none gave us the full face. And the emotional toll was beginning to show. For young researchers, this was exhilarating chaos, a chance to ride the wave of paradigm shift. But for others, those who had spent decades building the edifice of the known, it was an existential tremor. Careers had been built on the Standard Model, on inflationary cosmology, on the lambda CDM model of the universe. Now, those pillars stood like ancient statues, eroding in the wind of new data. The equations still worked. But were they right? What if our theories were not maps of truth, but temporary illusions of order? Philosophers of science began to circle back into the conversation. They reminded us, science is not the search for certainty, but the management of doubt. And yet, this doubt was different. It wasn't just epistemic, it was ontological. It questioned the very fabric of what we called real. What is a particle, if it can exist and not exist? What is a force, if it behaves differently under observation? What is time, if galaxies evolve faster than time allows? And most haunting of all, what is truth in a universe that rewrites itself? Some theories suggested that we were misreading the cosmos because we were embedded within it, that like ants crawling on a painting, we couldn't see the image because we were part of the brushstrokes. Others argued that the laws of physics weren't fundamental at all, but emergent, like temperature or pressure. That deep down, the universe may be lawless, or governed by principles so alien that our minds, shaped by evolution and entropy, simply cannot grasp them. And in quiet corners of research centers, a more radical idea emerged. What if the theory of everything does not exist? What if unification is a human desire, not a cosmic necessity? The idea was not defeatist. It was humbling. That perhaps the universe was not built to be elegant. Perhaps it was fractured, contingent, a mosaic of laws, patched together from deeper, unknowable truths, a multiverse not of infinite spaces, but of infinite rules. And still, the anomalies persisted. In one stunning turn, researchers at CERN observed correlations between entangled particles that exceeded theoretical limits, suggesting that either faster-than-light influence existed, or our understanding of causality was incomplete. Entanglement, long thought to be strange but safe, now appeared even stranger. The very scaffolding of space and time, once considered unshakable, was beginning to tremble. Conversations turned metaphysical. Were we glimpsing the edge of simulated space? Was the universe emergent from information itself? Was consciousness, in some inexplicable way, woven into the collapse of probability? In this new landscape, every answer bred a dozen new questions. What started as a discovery had become an unraveling. And yet, in the confusion, there was a kind of beauty, because never had we stood so naked before the unknown. Never had we so clearly seen the limits of our knowledge. The universe was no longer a machine to be decoded. It was a story unfolding, one in which we were not the authors, but characters trying to read the next page with a flickering candle. We were no longer just physicists. We were poets of uncertainty, interpreters of paradox, explorers of an ocean with no shore in sight. And as the darkness deepened, so did the longing, not just to understand, but to belong, to find a place in a cosmos that now felt infinitely more mysterious than ever before. The machines kept running, the data kept coming, the theories kept multiplying. But beneath it all, a quiet voice lingered, a reminder from the edge of science and soul. We are not lost, we are looking, and the mystery has only begun to reveal itself. Out there, beyond the spirals of galaxies and the glow of ancient starlight, the universe drifts in silence. A silence so vast, it defies language, so total, it becomes a mirror. And in that mirror, we are reflected, not as we are, but as questions in motion. From the beginning, we have tried to separate things, matter from mind, particle from planet, observer from observed. But the farther we've chased truth into the heart of physics, the more those boundaries have blurred. The anomalies we now see, the rogue particle, the impossible galaxies, the fractured laws, do more than disrupt equations. They whisper of a deeper entanglement, one that stretches beyond math and touches life itself. Because this is not just about atoms, it is about being. For every particle that collides in the halls beneath Geneva, there is a distant echo in a living cell, in the neurons firing in your brain, in the spiral of your DNA. Every law we write in a textbook is echoed in the structure of a tree's branch, the arc of a bird's wing, the rhythm of a heartbeat. This strange new physics we're uncovering, it lives in us too. And in this chapter of discovery, we are beginning to see that the cosmos is not just a stage for life, it is a participant, the force we thought we understood, entropy, the great dissolver, has always told a clear story. Everything falls apart. Stars burn out. Heat spreads. Structures decay. And yet, despite this constant drift toward disorder, life emerges. Order arises. Eyes evolve that can look back at the stars. Minds awaken that ask, why is there something rather than nothing? And now we are beginning to ask, what if life itself is not the exception to entropy, but a product of it? This new anomaly we've found, a particle that warps its surroundings, galaxies that form too soon, suggests a universe more active, more coherent than we imagined. One that doesn't just permit complexity, but cultivates it. In the patterns of light from ancient galaxies and the subtle shifts in subatomic behavior, we begin to sense a current, a tide. The universe isn't just expanding, it's organizing. Imagine a vast river of time flowing forward with increasing complexity, not uniformly, not smoothly, but with eddies and surges. Life, consciousness, even history may be not accidents along that river, but inevitable bends in its path. The laws of physics, once thought cold and impersonal, now appear to make room for warmth, for memory, for awareness. And that leads us to the most haunting implication of all. What if the universe wants to be seen? Not in a mystical sense, but in a structural one. What if consciousness is not a fluke, but a function? A natural consequence of matter arranged in certain ways, inevitable, given time and structure. From hydrogen to humanity in 13.8 billion years, not by chance, but by necessity, a slow bloom of complexity, destined to open eyes upon itself. You, listening now, are not an accident. You are the cosmos thinking. You are stardust remembering the sky. And these discoveries, the ones that challenge our theories, that unmake our models, are not just scientific milestones. They are reflections. The particle we discovered behaves differently depending on what surrounds it. It adapts. It resists definition. It changes the space it occupies, gently altering the rules of proximity. And that behavior is echoed in living systems, where context defines meaning, where interdependence is the rule, not the exception. In biology, we see the same song playing at a different scale. The brain is not a machine. It is a field of interactions. It is a symphony of probabilities, where attention shifts outcomes and thoughts reshape their own origin. The same uncertainty that governs the quantum world ripples through the experience of a moment, through choice, through perception. Is this coincidence or connection? For centuries, we have tried to keep physics and consciousness apart. One belonged to stars, the other to souls. But now, through this strange new science, this unraveling, shimmering frontier, we begin to sense that perhaps they are facets of the same jewel. That to understand the deepest layers of the universe, we may also need to understand the self. Because consciousness is not just awareness. It is pattern recognition. It is integration. It is the universe folding complexity into a single point of view. And in that view, everything converges. Life and death, chaos and order, matter and meaning. Entropy tells us that all systems move toward disorder. And yet, here we are, arranging language, building cathedrals of knowledge, tracing galaxies. On digital screens, if entropy is the backdrop, consciousness is the spotlight. We do not defy the laws. We ride them, like surfers on the waves of decay, building castles from the foam of impermanence. And when the last star fades, when the universe grows cold and thin, what will remain? perhaps only the record of thought, the residue of structure, the echo of memory encoded into the final bits of radiation. Perhaps, in some unknowable way, awareness continues, not as self, but as imprint, as signature. And so we zoom out, beyond Earth, beyond the Milky Way, beyond even the observable cosmos. We see galaxies as neurons, dark matter as scaffolding, gravity as the great weaver, and us, not as passengers, but as participants, as one branch of a cosmic tree, blooming briefly, beautifully. The theory of everything was never just about unifying equations. It was about unifying experience, about seeing the connection between the dance of atoms and the birth of stars, between the warmth of a hand and the fire of a quasar. It was about realizing that all of it, all of this, is one unfolding story, told in the language of laws, but lived through the poetry of being. And now, with these discoveries that defy categorization, that refuse to obey the rules we wrote for them, the universe is turning the page. What comes next? We cannot say, but it will not be cold. It will not be simple, and it will not be silent. Because we are listening now, not just with machines, but with meaning, and the cosmos is beginning to answer. In the stillness between revolutions, in that fragile space where silence hangs just before the next breath of understanding, something shifted, not loudly, not with fireworks or celebration, but with the quiet finality of a puzzle piece falling into place, only to reveal that the picture we thought we were building was upside down. The data had continued flowing. Particle collisions, light curves from distant galaxies, quantum experiments that should have yielded familiar patterns but didn't. The anomalies, once scattered like cosmic misprints, began to form a strange kind of constellation. And then, almost reluctantly, a realization began to emerge. It wasn't just that something was missing, it was that something had been misread. We had been asking the wrong question. For centuries, we built our understanding of the universe on a single assumption that the laws of physics are fundamental, immutable, absolute, that gravity bends space-time, that particles obey quantum fields, that entropy increases. These were not opinions. These were pillars. But what if they weren't? What if the laws themselves were emergent? The idea had existed in the margins of theory for decades, once dismissed, occasionally entertained, rarely embraced. But now it demanded attention. The data, the rogue particle with inconsistent mass, the early galaxies too structured to be primordial chaos, the localized shifts in expansion, were pointing toward a deeper truth. That the universe, at its most fundamental level, might not be made of matter or energy, but of information. It was a wild idea, yet strangely familiar. If space-time itself is emergent, woven from quantum entanglements, then everything we see, mass, time, dimension, is a higher-order pattern, a consequence, not a cause. The particle anomalies, localized tears or folds in this deeper informational network. The early galaxies, emergent structures in a computational landscape far more efficient than physics had previously imagined. Suddenly, it made sense. Terrifying, beautiful sense. The universe is not a machine. It's a process, a cosmic computation, constantly evolving, optimizing, reframing its own rules, and we, our bodies, our thoughts, our science, are patterns within that unfolding. It was a revelation so profound it threatened to unmoor us. For if this was true, then all our previous theories, the standard, model, general relativity, even quantum mechanics, were not wrong, but limited perspectives, projections of something vaster. Like shadows on the wall of Plato's cave, they described real things, but not the source. We had been drawing maps of rivers without realizing they floated in an invisible sea. And this sea, the informational bedrock of reality, was not governed by particles at all. It was governed by relations, by entanglements, by the context in which things existed. Space was not a stage, but a consequence. Time was not a flow, but an ordering of information. And consciousness was not a visitor to this system. It was native to it, not supernatural, not separate, but a recursive loop in the cosmic code, a feedback structure that could reflect upon itself. In that light, our journey to discover the theory of everything had always been misnamed. We weren't trying to understand everything. We were trying to understand meaning. From the first myth of gods forming the world out of chaos to the LHC, smashing protons together in search of hidden symmetries, we had always been looking for a narrative that placed us within the cosmos, not as accidents, but as expressions. And here it was. Not a formula carved in stone, but a recognition. Our pivot. The twist was not in the data. It was in us. We had spent centuries chasing laws across the stars, building machines, refining models, peering ever outward, while the key had been hidden in our assumptions. It was not what we looked at, but how we looked. Poetic, isn't it? That the universe would teach us its most sacred lesson by turning our eyes inward, not into ourselves, but into the nature of observation itself. That by studying particles, we would learn about perception. That by charting galaxies, we would uncover the architecture of awareness. That the theory of everything would not arrive with thunder, but with a whisper. You've been part of it all along. The unexpected particle? A local irregularity in the informational field. Not a flaw, but a message. A flag planted in the code, daring us to notice. The early galaxies? Not mistakes, but previews. Artifacts of a system that doesn't wait for permission to become complex. The tension between relativity and quantum mechanics? A clue that we've been trying to unify shadows, not the fire, casting them. The truth had never been hidden. It had only been unrecognized because we were so certain that reality was out there, distant, external, separate. But in truth, it was never out there. It was everywhere, woven into each moment of attention, each observation, each curiosity, and it had been waiting for us to learn how to see. In the end, the twist was not that we discovered something new. It was that we recognized something ancient, that the cosmos is not a cold equation, but a living question, that we are not passive observers, but dynamic participants, that the theory of everything is not just a scientific ambition, it is a mirror, and, in that mirror, slowly, softly, we saw it. It was there, all along. We just didn't know how to look. It is a strange thing to discover the nature of reality, only to find yourself in it more deeply than ever before. For centuries, we've looked to the stars with wonder, imagining them as distant, majestic, indifferent. We built telescopes and colliders, not only to know the universe, but to separate ourselves from it, to measure, to define, to contain. But now, after all the discoveries and disruptions, the paradoxes and revelations, a new understanding dawns, and it is not cold, it is not detached, it is intimate. The universe is not a thing to be observed from afar. It is a process that flows through us. It lives in our questions. It responds to our perception. And in this new light, we begin to ask, not, what is the universe made of, but what are we now that we know this? The implications stretch farther than technology. They seep into the very fabric of how humanity will understand itself moving forward. Because if reality is emergent, woven, from information, context, and relationship, then everything we do as a civilization is an act of participation in the cosmic unfolding. Science is no longer a window, it is a mirror. Technology is not just a tool, it is an extension of cosmic evolution. And humanity is not a species of clever animals. We are a function of the universe becoming aware of itself. And that changes everything. First, it reshapes how we approach knowledge itself. Our theories are not final blueprints, but evolving languages. They are stories the cosmos tells about itself through us. There is no end to science, no final theory etched in the sky. There is only deeper coherence, more refined meaning. As we continue to uncover new particles, new cosmological anomalies, new aspects of quantum geometry, we must begin to see every insight not as an answer, but as an invitation. Our learning is not about conquest. It is about connection. Second, the discovery reframes our place in the timeline of the cosmos. We are not early, nor are we late. We exist at a moment of exquisite tension, a species on the cusp of technological power vast enough to destroy itself, and understanding deep enough to transform that power into wisdom. The recognition that we are entangled with the universe at a foundational level, that our consciousness, our agency, even our ethics may be emergent properties of the cosmos, demands a new kind of responsibility. Because if the universe wants to be known, if awareness is a structural feature of reality, then to destroy ourselves would be to snuff out a flame the universe took eons to light. We are not separate from the fate of the cosmos. We are part of its fate. And so, the future demands caution. But also courage. We must face our existential risks with this new lens. Artificial general intelligence, climate collapse, synthetic biology, these are not simply technological thresholds. They are tests of consciousness itself. Will we wield our new knowledge as toddlers playing with fire? Or will we evolve into something wiser, more integrated, stewards of complexity rather than consumers of it? If reality is built from information, then truth matters more than ever. Misinformation, distortion, ignorance, they are not just social failings. They are violations of reality's structure. They weaken the coherence we now know is essential to emergence. A fragmented human mind produces a fragmented world. But a coherent mind, a civilization that sees itself as part of the same wave function, can change everything. In practical terms, the implications are stunning. The unification of quantum mechanics and relativity under an informational paradigm unlocks new doors in quantum computing, energy systems, and material science. The technologies of the future may no longer be mechanical but relational. Devices that interface with entangled fields, that harness coherence, that adapt based on context. Imagine power drawn from vacuum fluctuations, communication that is instantaneous across space-time, memory storage in quantum states preserved across cosmic time. These are no longer dreams. They are possible. And so are our missions. Already, new instruments are being proposed. Space telescopes that observe at quantum-sensitive frequencies, gravitational wave detectors on the Moon, LHC successors that explore not just higher energies, but deeper symmetries. Missions to map entanglement across cosmic distances. Simulations that model not just particles, but emergence itself. We are moving beyond measurement. We are approaching participation. And with it, a new philosophy must be born. We must no longer ask, what can we extract from the world? But, what can we co-create with it? What kind of society aligns with a universe of entangled meaning? What kind of ethics, education, and economy emerge when we no longer see ourselves as above nature, but of it? Perhaps consciousness is not rare. Perhaps life is not an accident. Perhaps, scattered across the galaxies, are other beings undergoing this same awakening? Other civilizations rising from matter into mind, from curiosity into coherence, and maybe, just maybe, our greatest destiny is not to escape Earth or conquer space, but to join a conversation already in progress. One that spans stars. One that began before the first star ever formed. A dialogue of becoming, of knowing, of meaning. This discovery, the twist that reality is not a structure, but a process, not a law, but a language, doesn't just rewrite physics. It rewrites us. It suggests that humanity is not finished, that we are only just beginning to understand what we are and what we could become. That evolution is not limited to biology. It continues through ideas, through systems, through consciousness itself, and perhaps the theory of everything was never meant to be written in a book. Perhaps it is meant to be lived. Each choice we make, each moment of awareness, each act of curiosity, each embrace of awe. These are the echoes of the same process that forged the galaxies. So, what now? Now, we look to the stars, not just for answers, but for partnership. Now, we build, not just to survive, but to resonate. Now, we choose, not just what kind of world we want, but what kind of universe we become. Because we have seen the twist. And now, there is no turning back.